Okay, let's look at some exercises now. There are basically three types of exercises in the textbook in section 7.1. In the first type of exercise, you are given a like a set of premises, basically, or a set of lines, formulae that you have available to you. And the task is to determine what follows from those formulae by one of the rules of chapter 7. So for example, look at number 1 here. The information you have is that if G, then F. And you also have information that F is not the case. Do these two lines fit any of the patterns over here? Any of the rules that we have been studying? Well, obviously they couldn't fit disjunctive syllogism because disjunctive syllogism requires a disjunction, and there's no disjunction in if G then F and no F. It couldn't fit hypothetical syllogism because that requires two conditionals as premises, and obviously 1 and 2 are not two conditionals, only one is a conditional. What we have here is a situation where there's a conditional and then there is the negation of the consequent. So this is what you have. Just like here, there's a conditional and there's the negation of the consequent. So what is inferred is the negation of the antecedent. So the way to complete this exercise is to say if G then F and not F entail not G by lines 1 and 2, modus tollens, MT. That is the rule that is used. So you'll see this in the answer, not G by 1 and 2 modus tollens. So in these exercises, you're given some lines, and the question is, what follows from those lines? Is it possible to derive something from those lines by one of the rules? Sometimes you're given more than two lines. Consider number 7 here. You're given 3 lines that are all conditionals. So can you use 2 of those lines to take a step forward by using one of the rules? And obviously, because they're all conditionals, the only rule that you could possibly use is hypothetical syllogism, because that's the only rule that can put together 2 conditionals and get something out of them. With hypothetical syllogism, you have to have a conditional and then another conditional where the antecedent of that conditional is the same as the consequent of the other. And if you look over here, you should be able, just by looking around, to see that there are 2 conditionals, there are 2 lines here that fit that pattern. There's line 3, if F then H, the consequent is H, and there's line 1, if H then D, the antecedent is H. So if R then U and if U then B entail if R then B. And here if F then H and if H then D entail if F then D. It's going to be slightly confusing because here you're going from the top to the bottom. It's kind of like you're using U to kind of go down the stairs and go from R to B and put them together in a conditional. Here you're going up the stairs. If F then H and if H then D, they entail if F then D. So what you would put on line 4 is if F then D, you would justify it as 3-1 hypothetical syllogism or 1-3 hypothetical syllogism. It doesn't matter in which order you list the lines. So this is one type of exercise. You're given lines, you have to find two of those that go together in accordance with one of the patterns of reasoning: modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism. Then there's another block of exercises where you do something slightly different. It's a good exercise because it forces you to be flexible in your thinking. So here you're told one of the starting points and your point of arrival, and you have to figure out how you got there or how you can get there. If you know that one of the starting points was B or K, and the point of arrival is K, what must have been the second formula that you used to get to K? How can you get K alone from B or K? So look at the rules. Is there a rule that allows me to start with an either or and then detach the or part, the part that comes after the wedge? Well, there is one, of course. It's disjunctive syllogism. If you have C or U and not C, you can infer U. Over here, you had B or K, and you inferred K. So what must have been on line 2? Obviously on line 2 you must have had, or you should have had, not B. That is the only formula that would allow you to infer K from B or K. So the response to this exercise is to say on line 2 there must be not B, and then K is derived on line 3 by lines 1 and 2 disjunctive syllogism. So that is the answer. Oh, the textbook didn't include the rule, but not B is what goes down here on this bar in place of this blank, and then for this blank you would write 1, 2 disjunctive syllogism, or DS. Okay, sometimes it's a little bit more complicated. Let's find another example. Let me see if there's one that, yeah, this would work, for example. This might require a little bit more thinking. But here your starting point was if C then H, then you had another starting point that you have to figure out. And your point of arrival is if R then H. So you must have used a rule that allowed you to use a conditional together with something else to get a conditional. And really, over here, you can see that the only rule that allows you to get a conditional is this one. Starting with a conditional and using a second conditional. So here on line 2, there must be another conditional. But not any conditional, right? Because we have to find a conditional that goes with the other conditional in a way that would allow you to derive if R then H by hypothetical syllogism. Hypothetical syllogism allows you to put together two conditionals so that you end up with a third conditional that has the antecedent of one of those two conditionals and the consequent of the second. Okay, so here the consequent is H and the antecedent is R. So your second line here must have been a conditional that had R as the antecedent and C as the consequent, because that way you have if R then C, which you put here on line 2, and if C then H, that entails if R then H. Okay, so let me do it over here. If you have if R then C and if C then H, then you can infer if R then H. So on this side, if you inferred if R then H and you had if C then H, the missing piece of the puzzle is if R then C. So the solution here is to write if R then C on line 2, and then on this blank next to line 3 you write 1 and 2 hypothetical syllogism, or HS. Okay, so if R then C is the missing piece on line 2, and then you write 1, 2, HS here. I'll stop here. There's a third kind of exercise, how to do complete proofs, so I'll make another video on this.